Now, there's another thing which we have to consider when we're sizing valves. And to explain this, I'm going to talk about my garden hose. When we're talking about flow doesn't behave the same way as electricity does. If you try and push flow too quickly, it goes beyond what we call turbulent flow, and it goes into chaotic flow, and then horrible things start happening, like it gets jammed up. It's a bit like if you had 200 people in the room and you shouted fire and they all tried to get out one door. What would end up happening is nobody gets out the door. Whereas if you let them slowly go out and you just let them out slowly, they will go out slowly. So that's a bit like what happens with chaotic flow. Now, here's a system. I've got a garden hose. I've got a pipe coming down the wall. This is a pipe coming down the wall. I've got a tap, and then attached to the tap is my green garden hose. And in true garden hose fashion, it's lying around all over the place. I go along to my tap, and I open it one turn, and I get some flow. Say, I don't know, 5 litres per minute. Then I open it a second turn, and I get a bit more, say 8 litres a minute. And then I open it a third turn and a fourth turn, and I don't get any more flow out of the thing. Now, what's happened is some part of the system, in this area here, the first 2 turns, the valve, the tap, in the first 2 turns, the tap is the biggest resistor in the system. With flow, whoever's the biggest resistor, that's the person that's in charge. Whoever is the biggest resistor has got what we call authority over the flow. The biggest resistor is controlling the flow. It has authority. So for 2 turns, the tap is the biggest resistor. And then we get to 8 litres a minute, and then we got 2 wasted turns. Here, the tap is no longer the biggest resistor. Looking at the garden hose system, what do you think is the biggest resistor in the system after 2 turns? Yeah, it's the hose. The hose which is lying around in a bloody great big pile with bends and kinks and that's what's taken over authority. Now, tricky question. Would the flow increase if I made the tap bigger? No, because we're not going to get any more through that hose. It doesn't matter how big we make that tap. We're not going to get any more through the hose. The hose has taken authority. So, is the hose too big or too small? Sorry, not the hose. Is the tap too big or too small? Yes, the tap is too big. The reason the tap is too big is because it has 2 wasted turns. Basically, after 50% open, the tap, we don't get any more control out of the tap. The tap is too big. So, for fluid control, you get good control when the valve, when wide open, resists the flow as much as all the rest of the system put together. So the valve is the biggest resistor in the flow. When the valve is the biggest resistor in the whole flow, then you will have no wasted valve movement. we talk about this, we talk about a number which is the authority of the valve. It's a number. And the way we calculate the authority is it's a proportion of the pressure dropped across the valve. That's this thing. That's the pressure dropped across the valve. And that's delta PV, pressure drop across the valve, divided by the pressure drop across the whole system, where the whole system includes the valve. So for the hose pipe system, let me just draw that quickly. For the hose pipe, the authority is, that's the pressure drop across the valve. That's the pressure drop across the whole system. What the authority is how much of the entire system pressure is dropped across the valve. So, if we want to get no wasted turns, I'll just come to that. If we want to get no wasted turns, then the valve has to be the biggest resistor in the whole system. Now, N must be a number between 0 and 1. Because really, the pressure drop across the system is kind of like the pressure drop across the valve plus the pressure drop across the rest. That's an R. R for rest. Everything else, which will be the pipe plus the hose pipe. So, it must always be less than 1. So, authority is always a number between 0 and 1. So, it's the proportion. It's the amount that's dropped across the valve. Are we okay with that to move on? I guess what I'm trying to say is, if half of the pressure is dropped across the valve, then the authority is 0.5. If a quarter of the pressure is dropped across the valve, the authority is 0.25. And along those lines. Now, here I've got an exercise for you. A circuit has a total pressure drop of 125 kPa, which includes the valve. If the authority must be 0.4, what pressure drop is used to size the valve? So we're going to use the equation N equals pressure drop across the valve divided by pressure drop across the entire system. And what I need you to do is I need you to find what N is when pressure drop across the entire system is 125. Sorry, I don't need you to find N. I need you to find what delta PV is. So I'll let you have a little go at that. Calculating what delta PV is. 16 equals PV. Oh yeah, I just made a huge mistake. Let me just correct that. Start that again. N equals delta PV over delta PS. N is 0.4 equals delta PV over 125. There, that's better. You've got it, it's 50. Now, the easy way to think about this is the authority is the proportion of the pressure which is dropped across the valve. If the authority is 0.4, that means 0.4 of the pressure or 40% of the pressure is dropped across the valve. That's the easy way to think about that. Give us a little smile when you're all happy to move on. Okay then. Now, valve sizing and authority, what this actually means. Now, what we have to bear in mind is the bigger the valve, the lower its resistance. So bigger valves have got lower resistance. Now, larger kV, the valve size is its kV. So what that means is the bigger the valve kV, the less pressure is dropped across the valve. In electrical terms, what you'd have to say is that the less resistance of something, the less voltage drop there is across it. So the bigger the valve's kV, the lower its pressure drop, the pressure drop across the valve when it's wide open. Here's an example. I've got a pressure drop across the valve of 20 kPa is dropped across the valve. 100 kPa is dropped across the entire system. So I work out my authority, that's 20 divided by 100. 20 across the valve, 100 across the whole system. My authority is 0.2. Is the valve too big or too small? Okay, I'm going to need you to make some choices. So I've got A equals too big, B equals too small. So with this valve, I'm only dropping 20 kPa across the valve. Of the 100 kPa dropping across the entire system, I'm only dropping 20 across the valve. Valve too big or valve too small? Remember, the bigger the valve, the less drops across it. This one's only got 20 dropping across it. So, I reckon there's only 20 kPa dropping across this valve. The entire system's got 100 dropping across it. There's only 20 dropping across the valve. If you look at it, say we looked at it, there's the pressure at the beginning of the system. There's the pressure at the end of the system. That's the entire pressure drop. We're only dropping 20 across the valve. The valve's too big. Ideally, we need to drop half of the pressure across the valve. The ideal situation would be if 50 dropped across the valve and 50 dropped across everything else, which would give us an authority of 0.5. That would be the ideal situation. Okay, let's look at the other way round. This time, there's 100 dropping. I've got 100 there, I've got 0 there. I'm dropping 100 kPa across the entire system. I'm dropping 80 of those kPa in the valve alone. So the valve too big, valve too small. Well, hopefully, by a process of elimination, you would have worked out that the valve is too small. When we buy valves, if we had a choice between buying a valve which was slightly too big or buying a valve which was slightly too small, we would always err towards buying a valve that was slightly too big. In fact, we always try and buy a valve which is just slightly too big. Our perfect authority when you're buying a valve, the perfect authority is 0.4, because that means it's just slightly too big. It's got a little bit in hand, and that's what we would be aiming for mostly. But given a choice between buying one that's slightly too big and slightly too small, we'll always go with slightly too big, because then if the flow is excessively throttled, it's not our fault. So in that case, the valve is too small. 0.8, valve too small.